Now it says define the term molar mass of a substance, calculate the number of moles of water in 100 grams of water. Methyl benzoate is a compound used in wada. Determine the empirical formula, then define the term empirical formula, then determine the empirical formula, and then ask what's its molecular mass. Okay, so first of all, molar mass. The molar mass is basically what? It is the mass of 1 mole, but you can't say that. So the molar mass of a substance is the mass of 1 mole, where 1 mole is equal to the number of elementary particles that are on 1/12 of carbon 12. Okay, so you need to go and learn these, and basically you need to download your exam guideline or your CAPS document and go learn the definitions as stated there. Now it says calculate the number of moles of water in 100 grams of water. So we know the formula is number of moles is equal to mass over molar mass. If you're wondering where I'm getting that from, I actually do know it, but it is on your periodic table. So this is your mass in grams and this is your molar mass as calculated from your periodic table. So in order to do this question, grade 11s, you need a periodic table because we're going to be using it all the way through. So you need to go and get your periodic tables now. I'm not going to pop one up because usually they're too small to see anything anyway. So the number of moles is mass over molar mass. The mass we are given is 100 grams, so it's 100. The molar mass of water, so MH2O, is made up of 2 hydrogens, and the molar mass of hydrogen is 1, plus 1 oxygen, and the molar mass of oxygen is 16, so that is just 18. So the molar mass of H2O in this case is 18, and now we just need a calculator. Right, so we can say 100 divided by 18 equals 50 over 9, which is useless, which is 5.56. So therefore that is 5,56 moles, or 5,56 moles. Right, now it says methyl benzoate is a compound used in the manufacture of perfumes. It is found that a sample, 5.3 to 5 gram sample of methyl benzoate contains carbon, of which there is 3,758 grams, hydrogen, of which there is 0,316, and oxygen, of which there is 1,251. Okay, it says define the term empirical formula. Empirical formula is just the formula of the compounds in their perfect ratio. In other words, if we had water, the empirical formula for water would be H2O. But you could also get H4O2, or you could get H6O3. These are all water, except the fact is this is the empirical formula of water. Okay, so now it says determine the empirical formula of methyl benzoate. Okay, so the way we do this is we pretend that we've been given 100 grams. Okay, so first of all we need to change, no we don't. So what we need to do is realize that we've been given 3.758 grams of carbon, 0.316 grams of hydrogen, and 1.251 grams of oxygen. But we never ever work in grams. What do we work in? We work in moles. So we're going to divide each of these by their molar mass, okay, to get the number of moles. So I'm going to divide this by 12, I'm going to divide this by 1, and I'm going to divide this by 16, and that's going to tell me how many moles I've been given. So therefore we've got the calculator out. So we go 3.758 divided by 12 equals 0.31. So that is 0.31 moles of carbon. This is going to be 0.316, and I just want to check something. Oh, 313. Okay, this is 313. And oxygen, we're going to divide by 16. So it is going to be 1,251 divided by 16, which is 0,078, 0,078. Now, whenever we do this, we're looking at a ratio, okay? But we never ever look at a ratio with these funny numbers. What do we always do? We always go 10 to 1 or something like that. So what do we need to do? We need to divide all of these by the smallest number so we can get a ratio with respect to 1. So we're going to divide this by 0,078 because that's the smallest number, which means we're going to divide this by 0,078, and we're going to divide this by 0,078. So let's do that now. This is obviously 1. Okay, so let's use this in a calculator. So we've got 0,316 divided by 0,078, and that is equal to 4,05. So it's 4,05. Let's do this one as well just to see how much different it is. So you've got 0,313 divided by 0,078 equals 4,01. 4,01. So I think those are close enough that we can round them. So therefore we're going to have C4H4O, and that is our empirical formula. It's C4H4O. In other words, it's the basis for the methyl benzoate, is the fact that it's got this basic ratio of carbons, hydrogens, and oxygens. Now it says if the molar mass of the methyl benzoate is 136 grams per mole, what is the molecular formula? It says, what is the molecular formula? So we need to work out what this empirical formula is first. So we've got 4 times carbon, which is 12, plus 4 times hydrogen, which is 1, plus oxygen, which is 16. 4 times 12 is 48, plus 4 plus 16, which is 48, plus 20, which is 68. So the molar mass of this is 68 grams per mole. But they've said that they've given us that the molar mass of this methyl benzoate, what it actually is, this is the mass of the empirical formula. The molar mass of methyl benzoate is 136. So what we're going to do is we're going to see what that ratio is. And we're going to go, okay, fine, 136 divided by 68. Well, 6 goes into 13 twice. It means that you have a 1, and that gives you, so it's going to be 2 times. Therefore, this is half of the molar mass of methyl benzoate, which means we need to double these. So it becomes C8H8O2, and that there is the molecular formula of methyl benzoate. It's not how it's arranged, it's the molecular formula.